We are now on page 9. It says polynomials negative exponents. So just like the video before, if you have a negative exponent, it will become positive in the denominator. This case is 4 to the negative second. It will become positive in the denominator because below, 4 to the negative second would look like 4 to the second in the denominator, using 1 as your numerator of your fraction, and 4 squared is 16, so we just move straight across. However, the next example is a little bit tougher. You need to remember that the coefficient also has a positive exponent of 1. Because it has a positive exponent of 1, that does not mean that it moves to the denominator. It stays in the numerator. However, x to the negative second, that has a negative exponent, therefore that needs to move into the denominator. Therefore, our final answer is 4 over x squared. The next example is a power of a product using negative exponents. This is a mouthful. 2 to the first and x to the first. We take our exponent on the outside and multiply it to the 2 exponents inside our parentheses. This would look like 2 to the negative third and x to the negative third. Because I know that 2 to the negative third in our denominator is now going to be 2 to the positive third. X to the negative third is now going to be x to the positive third of the denominator. Because it's also grouped like that, I can just go straight forward and drop the whole entire problem into the denominator instead of breaking it up like I did here. So instead, we have 2, there's one more step in between here I think we should have in, 2 to the third, x to the third, because 2 has a power of 1 and x has a power of 1. Simplified, 1 over 8x to the third. So this last one has a lot of different ways you can solve this problem. So I'm going to do about the first 4 to 5 problems together. We have 4, no exponent, so we know 1. C, no exponent, so we know 1. And d to the negative fifth. When it has a negative exponent, it goes into the denominator and becomes positive. However, 4 and c are both positive, so that means it does not go into the denominator. Number 2, 3, no exponent, power of 1, a to the negative sixth. Because a to the negative sixth has a negative exponent, it will go in the denominator and become positive. 3 to the first has a positive exponent, therefore it stays in the numerator. Number 3. 3 doesn't have an exponent, power of 1, a to the fourth, b to the negative third. 3 to the first, that's positive, a to the fourth, that's also positive, but b to the negative third needs to go in the denominator and become positive. The rest of the problem has positive exponents, therefore it stays in the numerator. Number 4. This case, it has 4 to the negative fifth power. It's just like if it were a variable. 4 to the negative fifth power, the base is 4, the exponent's negative 5. We take negative 5, and what does it do? It becomes positive in the denominator, and we replace the numerator with the number 1. I'm going to do problem 17. I think that'd be helpful. X squared divided by y to the third, the whole quantity raised to the negative second power. So we can take the power on the outside, and you need to multiply it to every exponent you see in the inside. Multiply, multiply. X to the negative fourth divided by y to the negative sixth. What would happen here? X to the negative fourth is negative in the numerator, therefore will become positive in the denominator. Y to the negative sixth is negative in the denominator, therefore it will become positive in the numerator. Please complete the rest of this page.